Now we will discuss about the languages of push-down automata. Right? That is, the languages of push-down automata means it is similar to the languages of finite automata. Right? But here the acceptance is by two different ways. One is the acceptance of the language by emptying the stack, and second one is the acceptance by reaching the final state. Right? In finite automata, the acceptance is only by reaching the final state. But here there are two different ways. One is by acceptance is by reaching the final state, and the other one is by emptying the stack. Right? See here, acceptance by final state means that is from the start state with the initial top of the stack as Z0 and the set of strings that is W. Right? By instantaneous description, it reaches the state that is Q. Here that will be considered as a maybe final state. Right? But if you are defining this as acceptance by final state means this Q is there, exactly the Q will be called as the final state. And there is no, here what is epsilon? There is no input symbol. Right? After reading all the input symbol, it reaches the final state. But stack is having some set of symbols alpha. Right? The stack will not be empty. The stack is having some set of symbols. But after reading all the input symbols, it reached the final state. Right? This is the acceptance by final state. And next one is acceptance by empty stack. Here Q0 from the start state with the initial top of the stack Z0 by reading the set of symbols W. Right? Here Q will not be, may or may not be the final state. But there is no symbols on the stack. Here the stack will be an empty stack. After reading all the input symbols, right? After reading all the input symbols, the stack is having no element. That is, the stack is now empty. Right? If the stack gets empty after reading all the input symbol means that is called as the acceptance by empty stack. These are the two different acceptance in pushdown automata. Acceptance by final state and second one is the acceptance by empty stack. Right? Now we will see an example. Design a pushdown automata for the language. L is equal to A par n, B par m, again A par n such that n comma m are integers by using empty stack. By using empty stack means that is at last the stack should be empty. Whether it reached the final state or not, that is not at all a problem. But the stack should be an empty stack. Right? For this language, how we will design a pushdown automata? Here, what are the operations for this particular language? Listen, A par n, that is n number of A's followed by m number of B's. Right? Here there is no restriction or there is no restriction between this n and m. But at last again it should be same n number of A's. Right? So how we are performing this operation means first we have to push the n number of A's onto the stack. First we have to push the n number of A's onto the stack. Again we have to push the B's, m number of B's onto the stack. Right? After that, right? Okay, we have first step is pushing the n number of A's onto the stack. Next one is again we are pushing number of B's onto the stack. Right? That is the normal operation based on the pushdown automata. But here we should not push this m onto the stack. Right? First we have to push A onto the stack. While reading B, we should not push B onto the stack. Just we read and change the state, but we should not push B onto the stack. Right? After pushing a number of A's onto the stack, just read B and change the state. Right? After reading the symbol B, again you are reading the symbol A. While reading the A's, n number of A's in the last position, it should be compared with the top of the stack. It should be compared with the top of the stack, and if it gets matched, it is popped out. Right? At last, the stack will be an empty stack. Right? So, the number of B's in the middle position is just, we have to read the symbol and change the state, but you should not push the B's onto the stack. Right? Now, how we will write the transitions for this? See here, first, yes, now we will see the transition for this particular language. Right? Initially, the stack will be like this. The Z0 is the initial top of the stack. Now the stack will be like this. The first step is, it is reading n number of A's. Right? N number of A's means the first A. If the first A is read by the particular pushdown automata, that particular A is pushed on to the stack. That is the first operation. Right? How we will write transition for this particular thing? Del of, consider the start state will be Q0. Consider the start state will be Q0. The first input symbol is A and the top of the stack is Z0. That is equal to the same state. Here we are not changing the state, right? The state will be the same, that is Q0. Here the A is pushed on to the stack. Now the stack is having A Z0, right? A is in the top of the stack. Next step, if you are reading one more A's, number of A's equal to n. If n is equal to 2, n is equal to 3, right? If n is equal to 2, number of A is 2. If it is equal to 3, number of A is equal to 3. Again, if you are reading A, second A means how we will, that second A is also pushed on to the stack. Right? The second A is also pushed on to the stack. That is like this. The second A is also pushed on to the stack. Here what is the transition? Respective transition is Q0, comma, the input symbol is again A. Now what is the top of the stack? The first A is pushed on to the stack. Now the stack is already having an A. Right? So the top of the stack will be A. It is equal to Q0, comma, AA. The top two elements are A and A. Right? If this particular transition will be repeated for n number of A's. Right? This is the first step with the top of the stack as Z0. If you want to read 100 A's means the same transition can be repeated for 100 times. Right? That is again if you are reading third A. For example, if you are reading third A means here also what is the top of the stack? The same A is in the top of the stack. With top of the stack as A, if you are reading the symbol A means what is the transition? Again the A is pushed on to the stack. Right? So this particular transition can be repeated for repeating the number of A's. Right? Next, after reading number of A's, here what symbol we are having? We are having the symbol B. Right? Next thing is from the state Q0, we are reading the symbol B with top of the stack as A. With top of the stack as A, you are reading the symbol B. Right? Here what is the process? We should not push B onto the stack. We should not push B onto the stack. Just change the state, right? Just change the state as Q1 and the stack. Top of the stack will be same. That is remains the same. Stack content remains the same. You should not push B onto the stack. Right? There is no restriction for this B. B is having some 10 A's, but B is having some 20 B's, 30 B's, 40 B's. There is no restriction or no relations between the number of A's and number of B's. Right? So you should not push B onto the stack. Just if you are reading the symbol B, change the state. Right? That is for representing the change of input symbol. Right? For that only we are changing the state from Q0 to Q1. But you should not change the content of the stack. Right? So what will be the next transition? After reading the number of B's. Right? After reading the m number of B's, again it is going to read the symbol A. Again it is going to read the symbol A from the state Q1. From the state Q1, again it is reading the symbol A with top of the stack as A. With top of the stack as A. Here already we are having some n number of A's. Again if you are reading the same n number of A's in the last position. Right? That A should be compared with the A's present on the stack. Right? That A should be compared with the A's present on the stack. If it gets smashed with this means this A is popped out. So for representing the pop operation, we are using the epsilon symbol. Here change the state as Q2 because we are reading the symbol. Again we are reading the input symbol A. So for representing the change here we are changing the state as Q2, comma epsilon. Epsilon is for representing the pop operation. Epsilon is for representing the pop operation. Next thing is from the state Q2. Here we change the state Q2, so it is not able to use the same transition for n number of times. Right? So from the state Q2, again you are reading the symbol A with top of the stack as A. It is also equal to Q2 comma epsilon. Again we are pop up the elements. Comparing the top of the stack with the input symbol, if it gets smashed, that element should be popped out from the stack. Right? After reading all the input symbols, here it is equal to epsilon. After reading all the input symbols means there is no more symbols. So here we use the symbol epsilon. Right? After reading all the input symbols, here we use the symbol epsilon. So Q2 comma epsilon comma, here what will be the top of the stack? Either it is equal to A or it is equal to Z0. If it is equal to A means that particular string will be called as a rejected string. So for rejection there is no need to write the transition. So it is equal to Z0. Here we guessed all the input symbols are read from the given string and it is matched and compared with the strings present in the stack. So Q2 comma epsilon comma Z0, that is equal to Q3 comma epsilon. Q3 comma epsilon. Here Q3 will be called as the final state and the stack is empty. Right? Here we mentioned the question. In the question we mentioned create the pushdown automata by using empty stack. That is, at last we have to empty the stack for the acceptance condition. So Q2 comma epsilon comma Z0 is equal to Q3 comma epsilon. Here Q3 is called as the final state. Right? Now how we will design an automata for this, pushdown automata for this? Graphical representation is, here what are all the states? Q0 is the start state. Right? Next Q1, Q2 and Q3. Here Q3 is called as the final state. Right? From Q0 to Q0, what are the transitions? From Q0 to Q0, we are having two transitions. From Q0 to Q0, we are having two transitions. That is, what are the two transitions? How we are representing the transition value? Input symbol, comma, old top of the stack by new top of the stack. Z0 by A Z0. This is the first transition. And what is the second transition? A comma A by AA. Your input symbol is A, old top of the stack and new top of the stack. And how we are moving from the state Q0 to Q1? B comma A by AA. From Q0 to Q1. From Q1 to Q2, A comma A by epsilon. From Q2 to Q2 cell transition A comma A by epsilon. From Q2 to Q3, epsilon comma Z0 by epsilon. This is the pictographical representation of the pushdown automata, and these are the set of transitions here we used for the acceptance case of this particular language. Right? Then how we will define this pushdown automata? What are the 7 tuples of the pushdown automata? First one is the Q. Pushdown automata P can be defined as Q, summation, pi, del, Q0, Z0 and F. Here what are all the set of states? The set of states are Q is equal to Q0, Q1, Q2 and Q3. These are the set of states. And what are the input symbols? A and B are the input symbols. What are the stack symbols? What are the symbols here we used in the stack? A comma Z0. Because B is not pushed onto the stack, so B will not be considered as the symbol of the stack. So stack symbols are A and Z0. And these are the set of transitions. Q0 is the same start state, Z0 top of the stack, and which one is the final state? F is equal to, final state is Q3. This is the definition for this particular pushdown automata. This is a graphical representation and these are the set of transitions. Right? Thank you.